Hi everybody and welcome to a new video in the Generating Melodies with LSTM Networks series. Last time we continued our journey into pre-processing our song dataset, and specifically we created a single file with all the songs that we want to pre-process, and then we created a mapping between the symbols that we are using in our time series music representation and a bunch of integers. This time we are gonna get to the final stage of pre-processing, and I promise you this is the last video on this, but I hope by now you understand how time consuming and how involved pre-processing is. Okay, so what are we gonna do today? First of all, we are gonna basically convert the songs that we have in our dataset with our symbolic notation into integers. So we're going to map our song dataset to integers, and then we're going to finally create sequences that we'll use for training our LSTM network. So let's get started. The first thing that I want to do is to create a new function, which I'll do down here. And so we can have this. Okay, so we'll define a new function that let's call it convert songs to int. Okay, good. Okay, so this function takes as input songs, which is a string that contains all the songs in our dataset, which is basically this guy over here, right? So we load this, and then we load this as a string, and then we pass it to convert songs to int. Okay, so for this function, we need to do a few things. So first thing that we want to do here is to load the mappings, and the mappings are these guys here. So it's this JSON file here. We want to load this as a dictionary and use it for just mapping the song dataset. Then we want to cast songs string to a list. And finally, we want to convert songs to, well, let's say we want to map songs to int. Okay, so let's start by creating an empty list that we'll call int songs. And so here we'll store our dataset and all the mappings which are with integers. And then we want to load the mappings. And as I said, we want to load this file here. And so what we can do for doing that is using with open, then we'll pass in the path to the single file datasets, which is this guy here, and then we'll say that we'll open this in this file in reading mode. So we'll say as fp, and we'll do a mappings is equal to JSON dot load, and I'll pass in fp. Now this JSON I've already imported as a Python package in a previous video, so I don't need to re-import that. Okay, so here with these mappings we're going to have a dictionary containing all our symbols as keys, as you can see here, and then all our mappings, int mappings as values for the respective keys. It's basically a simple lookup table. Okay, so now we want to cast the songs string to a list. Okay, so here we can just do songs is equal to songs dot split, and as you're already familiar with this function, it basically just like splits a string and using empty spaces and creates a list out of all the items that we have in our string using the empty spaces as separators. Okay, so now we want to map all the symbols in our songs list to the relative integers. So how do we do that? Well, this is quite straightforward because we can say for symbol in songs. So we go through all the symbols, loop through all of them in our song dataset, and then we do a int songs.append, and we want to append the relative mappings. And so we take the mappings dictionary, and then we look up the value correspondent to our symbol key. Okay, so once we go through all of this loop, we now have a mapping of our symbols of all of our songs, which are integers. And so now we are ready to return the int songs. Good. So this is all we need for converting our songs to a list of integers. And so now we arrive at the very interesting stuff, which is generating the training samples. So generating, yeah, let's call this like sequences, training sequences. Okay. And so here we want to pass as an argument the sequence length. Okay, so now let me explain what these sequences are and why we need them. Well, so in order to train our neural network, so we are going to get these sequences that basically are subsets of our time series or our song dataset represented with music, with a time series music representation. And so we're going to feed these sequences into the network, and then we are going to have also like targets for that. So this is a supervised problem. So we are basically addressing this problem as a supervised task. And so we're going to need to have both inputs and relative targets. So as I said, the inputs are going to be fixed length sequences or subsets of our time series input dataset, and then the targets are going to be the value, that item that comes just after each sequence in the time series. So I know this feels a little bit difficult to get because it's a little bit abstract, I guess, but let's see an example so we can clarify this. Okay, so let's assume that our song dataset looks something like this. So 11, 12, 13, 14, and then, yeah, we just continue. So here we have our time series with our mappings for the different symbols. And here we just focus on 4 items, and then, yeah, we're going to have like way thousands or hundreds of thousands more, but we don't care about that. Okay, so now let's assume we want to create sequences of a length 2. So as I said, here we're going to have both inputs and targets, okay? So for each sample, for each training sample. So regarding the input, so if we were to start from the beginning of this time series, we would pick these 2 initial items, and so this would be 11 and 12, and the relative target here would be 13, right? So which is the item that comes just after the input sequence. But we're not happy with having just a single sample, right? So we want to create other samples. And so how do we do that? Well, this is very, very simple, because all we do is, starting from the initial sequence, we just slide it to the right, okay? And so now we are focused on these 3 other items here. So for the inputs, we'll focus on these 2 items, so 12 and 13. Here we go, 12, 13. And for the target, we're going to have 14, right? So we can continue like this until we hit the end of our dataset, of our time series. Okay, so now I want to draw your attention on what it means. So what these inputs and targets actually mean. So basically what we are doing here is a simple time series prediction in the end. So we are assuming, so we are passing in as inputs to the network a sequence, and then we are asking the network to predict the next item in the time series, okay? And what this means musically is that we are just passing some historical information about a melody, and now we are asking the network to predict the next note, the next musical event in the melody, given a certain historical data regarding a melody. Good. The great thing about what we are going to do here is that we're going to have 64 time steps for each training sample or input sample, which basically will guarantee us to have quite a lot of information about the behavior of a melody. So the LSTM is going to be able, hopefully, to pick up and understand memory-wise how to predict the next event in melody given a certain history of the melody itself, which in our case is going to be equal to 4 bars of 4/4, which is a quite substantial and meaningful length of music. Indeed, 4 bars is usually what you have for a full musical phrase, which is a kind of meaningful piece of music in itself. Okay, so I hope you have an idea of how this training is going to work and what these sequences basically mean. But now let's implement these sequences. Okay, but so let's just take a look at the different steps that we need to implement in this case. So the first thing that we want to do is just to load the songs and convert them to integers, map them to integers. Yeah, I should use map instead of convert them, right? So it's more like a mapping here. Okay, so then the next big chunk in the implementation of this function is to generate the training sequences. And finally, we want to hot encode the sequences. Now, if you're familiar with machine learning, I'm sure you'll know about hot encoding, but if you're not, please don't despair because I'm going to cover the basics of it when we get here. Okay, so let's start from the beginning. So we want to load the songs and map them to the integers. Okay, so for doing that, we are going to do a songs is equal to load. So we're going to invoke the load function. That's a custom function that we've just implemented here and just loads a text file. And here we need to pass the path to the single file dataset, which is this guy here. Okay, and then here we'll have a string that contains all the symbols for our song dataset. Now we want to convert that and map that to int songs. And for doing that, we'll use our newly implemented function called convert songs to int, and we'll pass in these songs. Okay, so now we have the list of our with all the symbols and all the symbols mapped to int for all of our dataset. Now we want to generate all the training sequences. So now the first thing that we should think about here is how many sequences can we generate or should we generate here? Okay, so for responding to that question, we can just have an example here. So let's assume we have a dataset that only has 100 symbols. So very, very short dataset. And let's assume here that we have a sequence length. That's the one that we are actually using for our dataset, which is equal to 64, right? So this is the sequence length. So the question is, how many sequences can we generate here, right? And the response is 100 minus 64, which is equal to 36. So we're going to be able to generate 36 sequences because each sequence is going to have 64 steps or items in it. Okay, So let's just get the number, let's call it number of sequences, so num sequences, and this is equal to the length of int songs. So I'm going to get all the amount of symbols that we have in our song dataset, and to that I'm going to subtract the sequence length, which in our case is 64. Okay, so now if we want to generate all the training sequences, we know that we need to generate num sequences, training sequences, right? And so for doing that, we'll create a for loop that we'll have a counter I, and we'll do a for I in range num sequences here. Okay, and so here we need to create a couple of things, obviously, right? So the inputs and the targets. So now we haven't declared them before, but we should. So we can create two empty lists. So one is called inputs, the other one is called targets. And we'll use this for appending the training sequences, right? So at each step, we'll append a new sequence. So we'll do a inputs dot append here, and then we'll take int songs, and we want to append a slice of int songs, which is equal to I and between I and I plus sequence length. Okay, so what this does, it basically at each step takes a slice of the inputs of the int songs time series, and then when we increase the counter here, we just slide to the right of the int songs time series by one step, right? So we're just moving right in our song dataset here. Okay. So what about the targets? Well, the target is extremely simple, really, because for the targets, we want to take the value that's correspondent to the I plus sequence length index of int songs, right? Okay, so here we have our inputs and targets. Okay. So now let's understand, first of all, what is one hot encoding, then how we get to basically moving from our representation of inputs and inputs to a one hot representation of the inputs. And for doing that, we should start by looking at the shape of inputs. So the shape, let me write this. So the shape of inputs is a two-dimensional list for the time being, where we have the number of sequences, which is the size for the first dimension of the list, and then we have the sequence length as the dimension for the size for the second dimension, right? So in other words, we have number of sequences, items, and each of these items is a list itself that has 64, in our case, items. Okay, so now let's try to to create an example that's like very, very simple here. It's a simplified version of what we are working with, and I'll explain what one hot encoding is. Okay, so now let's assume we have a input like this, 0, 1, 2, and then here we have something like 1, 1, 2. Okay. Oops. So here, I should just put a comma here. Okay. So these are the different sequences, for example. And here we have the first sequence, and here we have like another sequence, right? And so as you can see here, we have basically, let's assume we have a vocabulary size for each of these sequences that's equal to 3. In other words, the values that these guys can take is 0, 1, or 2. So there are only 3 possible categories. And this is some kind of categorical data because it can map different categories or classes onto integers. And here we have only 3 options, right? Okay, so now I can recreate this data structure into a one-hot representation by adding an extra dimension for each of these values. So now let's take a look at how this works. Okay, so I'm going to focus on this 3 guys here. Okay, so for the first one, I'm going to write this 0 as 1, 0, 0. This second value here, equal to 1, is going to be mapped to 0, 1, 0. And this third value here, 2, is going to be equal to 0, 0, 1. So as you can see here, the one-hot encoding uses a number of items which is equal to the vocabulary size of our dataset. In our case, simple example here is equal to 3. So we have 3 different numbers and 3 different items in the array. And then for having one-hot encoding, it means that out of all of these items, only one is going to take the value of 1. And then all the others are going to take the value equal to 0. And each position here represents a class, right? So 1, 0, 0 represents 0 value. The value of 1 is equal to 0, 1, 0. I mean, you get the idea. The important thing to understand here is also that the number of units that we're going to have in the input layer in the network is going to be equal to the vocabulary size of our dataset, or to the number of items that we have in each of these arrays. Okay, so now you may be wondering, but why should we care about doing this extra step of like putting all of this information into one hot representation? Well, that's because this is the easiest way we can deal with categorical data with neural networks, really. Now, in our example, so here we are not just going to have 3 items for each of these arrays. Rather, if we look at the mapping here, we're going to have 18 different values, right? Because we have 18 different symbols here in this mapping. Okay, so what changes when we move from this representation to one hot encoding is that the inputs is going to get an extra dimension, and that dimension, the size of that dimension is going to be equal to the vocabulary size. Okay, good. So now that we have a fair idea what one hot encoding is, we should just implement it, right? Okay, so, well, first of all, let's calculate the vocabulary size. And this can be easily calculated by getting the set of the insongs list. And this is going to just remove all the redundancies or repetitions in the elements that we have and focus only on one instance for each value. And then we just take the length of that. And so this vocabulary size in our example, as we've seen from the mapping.json file, is going to be equal to 18. Okay, so now that we have the vocabulary size, we can just create, just convert inputs to one hot encoding. And for doing that, we are going to need to import a Keras, because Keras has a very, very nice function that will enable us to do that without much hassle at all. So we'll do a import TensorFlow.keras. We'll import this as Keras. Okay, so now let's get back down here, and what we'll do here is saying inputs is going to be equal to keras.utils.to categorical, and we'll pass in the inputs, and we'll pass in the number of classes that's equal to the vocabulary size. Okay, good. So here, this inputs should be a three-dimensional array with this dimension now. Okay, so now the last thing that we really need to do here is to convert our targets list into a NumPy array. So for doing that, we need to import NumPy, and so we'll import NumPy as NP. Now, it may be that you don't have NumPy installed. If that's the case, you can just pip install it. Okay, so here we'll just go down here. We'll say targets is equal to np.array, and we'll pass targets in. So with this, we'll just cast this targets list to a NumPy array. Good. Okay, so finally we can return inputs and targets. Good. Okay, so now let's see these two functions we've implemented in action. For that, we should add an extra instruction here in this main function that we built in the previous videos. Okay, so here we'll say that we want inputs and targets, and here we should invoke this generating training sequences. Oh, this is a very nasty name, so let's just call it generate training sequences. Okay, so we'll call this invoke this generate training sequences, and we'll pass in this sequence length. Okay, so now I'm just create a dummy instruction here and create a breakpoint here, because I'm gonna run the debugger and we're gonna take a look at this inputs and targets variables here. So now, if there is no mistake in my code, we should be able to see this inputs and targets. So let's see what happens. As you can see, we have an error in the code, and I just figured out that I made a mistake here. So in the convert songs to int function here, I've passed in the single file dataset path, so the path to this file dataset, but what we want to do is actually open the mapping.json file, right? And so for that, we need this other path, so mapping path. Okay, so I'm gonna rerun this, and hopefully this time it will work. Okay, so here we go. So as you can see here, we can take a look at these two variables. So inputs and targets are these two guys here. So for the inputs, we have a NumPy array with 3 dimensions. So the first dimension is equal to 2512. That is the number of sequences that we have. Then the second dimension has a size of 64, and this is what we expected because this is the length of each sequence. Finally, we have 18 as the size for the third dimension, which again is what we expected because this is the number of categories, the number of symbols that we had in our mapping file. And as for the targets, this is correct because this is an array with only one dimension, and we have 2,512 items in this array, which is just the number of sequences that we have overall, which is fine. Okay, so this seems to be okay, which is great. So yeah, I guess guys, you can congratulate yourself because we've made it. Now we've gone through all the stages of pre-processing. So now we can generate all of the sequences that we can then easily feed into our LSTM network. So next time, we're going to start to do some really cool stuff, which is building the LSTM network itself and training it with the dataset that we have here. And for doing that, we're going to import a few of the functions that we've built here for pre-processing. Okay, so I hope you've enjoyed this video and you found it useful. If that's the case, remember to like the video and subscribe. If you have any questions, as always, feel free to leave them in the comment section below, and I hope I'll see you next time. Cheers!